58 on my test. The only multiple choice that I missed was number 4, so we'll start with that. So number 4 is basically a problem, really easy, which just focuses on impulse. So if we basically, a bullet was shot southwards with the momentum of 10 kilograms times meters per second, and and then it ricochets inelastically, and since momentum is always conserved, whenever it bounces off whatever it bounced off, I don't know what the D or whatever, it's still going at 10 kilograms meters per second. So it's asking for the impulse change in momentum, and that equation is mv final minus mv initial. Now, so let's just say that our final is our final, or basically our positive direction, is going northwards. So it would be, it wouldn't really matter, but basically it would be that, which is this one. And then since we're considering this one as our positive direction, this would be our negative direction, therefore this number has to be negative. So it would be parentheses minus negative 10 kilograms per second. And when you do the math, negative and negative, they cancel out to a positive, which gives us 10 meters per second, which would be C. Okay, the next problem that I messed up on was number 1A. So, a red cart with a mass of 15 kilograms moves to the right at 5 meters per second. A blue cart with a mass of 7 kilograms moves to the left at 2.5 meters per second. After the collision, the blue car moves to the right at 5.17 meters per second, and it's asking, we're trying to find the velocity of the red cart after. So we're trying to find, we're trying to find velocity. I'll put 1 for the red car final. So that's what we're trying to find. So first we can start with our givens. So our mass of our red cart is 15 kilograms. Its initial velocity, so V1 initial, is equal to 5 meters per second. Now, our mass of our blue cart is 7 kilograms. And then, this is where I messed up. The initial velocity of our blue cart was negative 2.5 meters per second. This is where I messed up. I actually put it positive because I disregarded the fact that it was going to the left while the red car was going to the right, so one of them had to be negative. And then we are also given our final velocity of the blue cart, which is 5.17. Okay, so from what we're given, and then from the fact that we're trying to find then the final velocity of the red cart, the equation that we're gonna use is m1 v1 initial plus m2 v2 initial equals I'm not gonna have space, m1 v1 final plus m2 v2 final. So okay, so that's the equation that we're going to use. Now, what we're going to try to do is we're trying to isolate the final velocity of the red cart. So to do that, we subtract m to v2 final on both sides, and then we also, I'll just do it on one, and then we divide by the mass of the red cart. So velocity of the red card final will be equal to m1v1 initial plus m2v2 initial minus m2v2 final over mass of the red card. And then whenever we plug all this in, we're gonna be left with, no, we're gonna plug it in right now. So in mass of the red card, 15 kilograms, and then the initial velocity, which is 5 meters per second, plus our initial mass, our mass of the blue cart, 7.0 kilograms, times our initial velocity, which is negative 2.5 meters per second. That makes a big difference. Minus, oh god, I don't have space again. Okay, minus 7 kilograms times 5.17 meters per second over our mass of the red card, which is 15 kilograms. And I don't have a calculator, so I'll be right back. Okay, so I had to use a calculator on my phone because I don't have one. But basically, we plugged it all in. We plugged in all of our givens for this equation. V1 final equals. So we plugged them in, and then here's like I did all the math, and we came out with our final velocity of the red cart, which is 1.42 meters per second. Okay, then the next one that I missed was number 1C, and it's just fairly simple. All you needed to know was the equation for elasticity. So it's basically saying to show equations, basically, to see whether a collision is elastic. And to prove that, since we know that within an elastic collision, kinetic energy is always going to be conserved. Therefore, the kinetic energy before is always going to equal the kinetic energy afterwards. And basically for that, all we really needed to know was the equation for elasticity, which I wrote it here, but I'll write it again. 1/2 mass times velocity squared plus 1/2 mass times velocity squared. This is before. So simply, if in the elastic collision, kinetic energy is always conserved, what you have before the collision must equal what you have after the collision. So simply, it would be what we have, the equation that we have for the first half will simply be repeated once more. And that's our equation, our answer for number 1C.